Welcome to the class. Today's topic is about theoretical distribution. In that we are going to see the next distribution, that is our binomial distribution. Next distribution is binomial distribution. Binomial distribution. First we will see the definition of this distribution. So definition: if x is a discrete random variable with PMF. We know that what is PMF? PMF is probability mass function. If the probability mass function of this is P of x equals NCX combination P power x Q power n minus x, and where x takes the values 0, 1, 2, etc. n, and this P will always lies between 0 to 1, Q is 1 minus P, then x is a binomial variate. The distribution of x is called binomial distribution. Okay, I'll repeat the definitions once again. If x is a discrete random variable, since this is a discrete probability distribution, so x is a discrete random variable with PMF, that is probability mass function, NCX P power x Q power n minus x. In Bernoulli distribution, we are having the PMF P of x is equal to P power x Q power 1 minus x. Okay. See here, there we are having only one trial. Here number of trials are more. We can take the trial till n, so that it is a combination of NCX P power x Q power n minus x. This binomial distribution is nothing but extension of Bernoulli distribution also. And as usual, x will takes the value 0 to n, but in Bernoulli distribution x can takes the values only 0 and 1, and p always range between 0 to 1, q is always 1 minus p, and if x is a Bernoulli variate, then definitely the distribution is, call it as a binomial distribution. Okay. Next, some examples I am going to give you. Number of x obtained in 4 tosses of a coin. In Bernoulli distribution only we will do the experiments once, only one time we will do. That is, only once we toss a coin. But here the number of x obtained in 4 tosses of a coin. If I toss a coin 4 times, that number of trials or the experiment is 4 times, so that I will get the different outcomes. That is the best example for binomial distribution. Number of male children in a family of 2 children. Number of bombs hit a target when 4 bombs are aimed at it. We don't know that if we aim 4 bombs, we don't know how many bombs will hit the target. But we are attempting, or we are doing this experiment 4 times. That is also one of the example for binomial distribution. Number of defective articles in a random samples of 6 articles drawn from a manufactured lot. Number of seeds germinated among 10 seeds which were sown. We don't know how many seeds are going to germinate. That is, but 10 seeds we are already sown, but we don't know how many outcomes will be our success. And next is, we have some features or properties in binomial distribution that we are going to see that. Some features. Binomial distribution. The first features. The parameter of a binomial distribution. The parameter of binomial distribution is n and p. Here we have 2 parameters, that is n and p. Next, the range of binomial distribution in is x can take the value 0, 1, 2, etc. n. This is our range. And next, for binomial distribution, PMF is P of x equals NCX P power x q power n minus x, and x can take the value 0, 1, 2, etc. n. P lies and q is 1 minus p. These things we know that is one of the features. And next, fourth is the mean of binomial distribution, that is expected value of x is n into p, and variance is npq, and standard deviation is square root of npq. Okay, and next is mean is always greater than variance, that is p is always greater than pq. Okay, these properties are same as Bernoulli only, but here we are having n values. Number of experiments are more. And the sixth one is the mean and mode are equal if np is an integer. The mean and mode are equal if n into p, if I take the product np, if np is equal, if np, the product of n and p is an integer, if it is an integer, that is our mean and mode, both are same. np is an integer. This we will see this property in when we solving the problems, we will see that. I'll repeat again. If p is equal to q is equal to half, the binomial distribution is symmetrical. It is symmetrical, or beta 1 is equal to 0. Okay, next, if p is less than half or q is greater than half, both are same. If p is less than half or q is greater than half, the binomial distribution is positively skewed, and beta 1 is greater than 0. Similarly, if p is greater than half or q is less than half, then binomial distribution is negatively skewed, and beta 1 is less than 0. I'll repeat this. If p and q, both the values are half, both are equal, so our distribution is symmetrical. It is in half of. Then the beta value, beta 1 or a skewed value is 0. If p is less than half and q is greater than half, or a q is greater than half, it will be positively skewed, then beta 1 is greater than 0. If p is greater than half or q is less than half, that is negatively skewed, or beta 1 is less than 0. And the last property, 10th property is the binomial distribution tends to Poisson distribution when n tends to infinity, p tends to 0, and np is equal to lambda. This lambda is a constant. This lambda is nothing but a parameter of Poisson distribution. So if n values goes on increasing, that is our number of experiments is increasing, and p value is going to tending to 0, and our np value, the np is nothing but the mean of a binomial distribution. This will be this np will be equal to lambda value. That lambda is the parameter of Poisson distribution. And the last property is the binomial distribution tends to normal distribution. The binomial distribution tends to normal distribution when n goes to infinity and p comma q are almost 0. equal. This is the last property, so that if the number of experiments are increasing, that binomial distribution can goes to Poisson distribution, and that binomial distribution can also tends to normal distributions also. So these are the 11 properties or features of binomial distribution. Let us solve some problems based on this distribution. In a binomial distribution, if n is equal to 6 and p is equal to 1 by 3, find mean, variance and standard deviation. First we will write the given, whatever they have given, n they have given and p they have given. N is equal to 6 and p is equal to 1 by 3. Since this is a binomial distribution, we want q value also. So q is 1 minus p, it is 1 minus 1 by 3, or it is 2 by 3. So p is 1 by 3, q is 2 by 3 and n is equal to 6. So mean or expected value of x is equal to n into p. The property says that expected value of x or mean of binomial distribution is np. N is equal to 6 into 1 by 3. It is 2 into 1, it is 2 only. And variance is equal to variance of x npq, that is 6 into 1 by 3 into 2 by 3, 4 by 3. 4 by 3, or it can be 1.333 recurring. And the standard deviation is square root of variance. This is square root of npq. This is square root of 6 into 1 by 3 into 2 by 3. This is equal to square root of 1.33, or this is 1.1547. You can just observe this. The property says that mean is always greater than variance. Here 2 is greater than 1.33. Okay. Next one. If a binomial distribution has mean 3 and variance 2, find the parameters. The parameters of binomial distributions are n and p, that we have to find. They have given the mean value and the variance value. So mean is equal to 3, this is nothing but our np, and variance is equal to 2, that is npq. Okay. We know that mean is always greater than variance. So we will take the ratio of variance and the mean. Take the ratio npq divided by np. This is 2 divided by 3. This is np will get cancelled. This will be q. So our q value is 2 by 3. After taking the ratio of this, we will get q value as 2 by 3. So p is equal to 1 minus q, p is equal to 1 minus 2 by 3, p is equal to 1 by 3. And next is, we will take the mean value. 3 is equal to np, or np is equal to 3. N I don't know. P value is 1 by 3 and 3. So n by 3 is equal to 3. Just take the cross multiplication. So n is equal to 3. 3 is a 9. N is equal to 9. So the parameters of the distribution p and n. P is 1 by 3 and n is 9. Yes, next one. 5 unbiased coins are tossed once. Okay, find the probability of getting first one 4 heads and 1 tail. More than 3 heads. Less than 2 heads. At most 2 heads. At least 1 head. So this is the problem they have given. Okay, they have not mentioned any values, n value or a p value or nothing. Here they have given 5 unbiased coins and tossed once. Okay, probability of getting heads and the tails, that we are going to see that. Okay, first the solution is like this. X is number of heads obtained. So number of heads obtained, so that x can take the values 1, 2, 3, 4, 5 because we have having 5 unbiased coins. So x can take the value 0, 1, 2, 3, 4 and 5 till 5. If x equals 0 means I will get the head value. I will get the head when I toss a coin. If it is 1, 2, 3, 4, 5, it will be a heads. And next here n is equal to 5 because we have tossed 5 unbiased coins. P is equal to 0.5 and Q is also 0.5 because I am tossing a coin. If I toss a coin, the probability of getting head and tail both are same, that is 0.5 or half and half. Chance of getting head is same as chance of getting a tail because in coin we have only 2 faces, only one face we can see when we toss a coin. So that P and Q is 0.5 and 0.5. So here now x will follows binomial distribution with 5 and 0.5 and x will follows binomial distribution with 5, 0.5. Next, write down the PMF of binomial distribution, that is P of x equals NCx P power x Q power n minus x. X can take the value 0, 1, 2 etc. n. Here I can take n will be a 5, so 3, 4 and 5. So next is, after this, after writing this PMF, we will see the problems whatever they have given. First problem says this, it is 4 heads and 1 tail. Okay, so probability of 4 heads and 1 tail, that is P of x equals 4. Why P of x equals 4 means, here x we have taken it as head obtains. So here the number of head is 4. So our P of x value is 4. So substitute x equals 4 in a PMF. It is NCx, n is equal to 5, C x equals 4 and P value is 0.5 and x equals 4, Q is 0.5, n minus x 5 minus 4. Once again I will repeat this procedure. You just see, we want to find a probability of 4 heads and 1 tail. Probability of 4 heads and 1 tail. 4 heads is nothing but P of x equals 4 because x we take it as number of heads obtained. X is nothing but number of heads obtained. Here number of heads are 4, so P of x equals 4. Substitute the values n, x, p, q in PMF, that is n is equal to 5, C, x equals 4, P is 0.5 and x is 4, Q is 0.5, n minus x, that is 5 minus 4. In your scientific calculator, you can find the value of IC4. That is a combination. In some calculators, that combination NCX button will be same as it is, or in some we have to see that. Okay. After this, the values are like this. 5C4 is 5 into 0.0625 into 0.5. This is 0.15625. So probability of x equals 4 is equal to 0.15625. Okay. Next one. Next is more than 3 heads. More than 3 heads. That is P of more than 3 heads. That is P of x should be greater than 3. More than 3 means it should be greater than 3. Greater than 3 means in x if we are having 0, 1, 2, 3, 4, 5. Greater than 3 means it should be 4 and 5. See here it is x is greater than 3. Greater than 3 is 4 and 5. This is P of x equals 4 plus P of x equals 5. Okay. Since this is greater than 3, so P of x equals 4 and P of x equals 5. This is 5C4, 0.5 to the power 4, 0.5 to the power 5 minus 4 plus 5C5, 0.5 to the power 5, 0.5 power 5 minus 5. Okay. For x equals 4, we have to write one PMF values, and for x equals 5, we have to write one more. Then you have to add these two probabilities. That is 0.15625 plus 0.03125. This is 0.1875. This is probability of x greater than 3. Next. Probability of x, third one is less than 2. Probability of less than 2. This is P of x is less than 2. Less than 2 means this side, that is 0 and 1. So this is P of 0 plus P of 1. This implies, okay, I'll write here only. It is 5C0, 0.5 power 0, 0.5 power 5 minus 0 plus for x P of 1 for x equals 1. This is 5C1, 0.5 to the power 1, 0.5 to the power 5 minus 1. After simplification, you will get 0. This is 0.03125 plus 0.15625. This is 0.1875. This is P of x less than 2. Got it? I split it this probability to P0 and P1. Then I'll substitute the values for the PMF. Next is probability of at most, yes, at most 2 heads. Since this is at most means it should be 2 or it can be less than or equal to 2. That is P of x is less than or equal to 2. At most means less than or equal to. So this is less than or equal to means less than 2 is 0 and 1, equal to 2. So P0 plus P1 plus P2. Here we have to combine all the 3 probabilities. So I'll write from here 5C0, 0.5 power 0, 0.5 power 5 minus 0 plus for P1 5C1, 0.5 power 1, 0.5 power 5 minus 1 plus 5C2, 0.5 power 2, 0.5 power 5 minus 2. After simplification, you will get the value 0.03125 plus 0.15625 plus 0.3125. So probability of x less than or equal to 2 or at most 2 is 0.5. So here we have to find the probabilities of 3 for P0, P1 and P2. So at last you will get a probability value as 0.5. And last is at least one head. This is P of x greater than or equal to 1. Say P of x is greater than or equal to 1 means 1 is also included and greater than 1 is 2, 3, 4, 5. So we should find the probabilities of 1, 2, 3, 4, 5. Instead of that I will take the contradiction, that is P of x greater than or equal to 1 is 1 minus P of x less than 1. See here it is greater than or equal to, since this is 1 minus, so it will be equality is also, here equality is there, here we will not take the equality, we will just take the less than 1. This is 1 minus P of less than 1 is 0, just it is P0, this is 1 minus 5C0, 0.5 power 0, 0.5 power 5 minus 0, this is 1 minus 0.03125, this is 0.96875. This is probability of x greater than or equal to 1. Whenever it is at least, if we take the contradiction, our calculation will be simple. So here it is greater than or equal to is there. So here in contradiction I will take only less than, I will not take the equality. Next class we will solve some more problems on this topic. Today we will wind up this class. Thank you.